Okay, we've made it to the end. This is just going to be a summary of what's in the chapter. What you should really do um, is read the chapter. Um, this is just a high-level overview of all the important information you'll need. Um, this is in Cengage MindTap, or you can buy it as an ebook, or you can buy it in Dead Tree. Whatever you want to do. Just as long as you're respecting copyright. Don't pirate it. That would be bad. People will stop printing books if we steal them all the time. So anyway, VirtualBox requires an x86 processor with um, a half a gig of RAM, ha ha ha, and 30 megs of hard drive space. What that really means is you need a modern processor with 30 gigs of 30 megs of hard drive space just to load it. And you should obviously have a whole heck of a lot more than half a gig of RAM. I think the last computer I saw, which only had 512 meg of RAM, I probably stopped seeing those 20 years ago. Um, though there was a time when having 256 meg of RAM in your computer was a big deal. Then having a couple gigs in your gigs of RAM in your computer was a big deal. Uh, Really and truly, particularly if you're going to do this stuff, not just in um, MindTap, but on your own machine, install VMware, install VirtualBox, install Hyper-V, build some VMs, play with it. Get as much RAM as you can. Particularly for larger systems like, say, vSphere, vCenter, you're going to want at least 4 gigs of RAM for vCenter, for vSphere, an ESXi host, and at least 10 gigs of RAM, over and above what the operating system needs to function, in addition to all the other VMs you're running at the same time, 10 gigs of RAM for the smallest possible version of the vCenter server appliance. If you have less than that, it literally won't spin up on you. We can use the Create Virtual Machine Wizard to build new virtual machines or add existing VMs to the VirtualBox Manager. It's not going to go find them for you any more than Hyper-V or VMware will do. With VMware, you can tell it to go look for them. Now, when you create a VM, you need to select a name. You need to select a guest OS type. Be specific, because that will give you some options. That'll lead you down the right path in terms of memory size. Select the type and size of the virtual hard disk, the file location, what format the VHD is in, whether it's dynamic or fixed, and in terms of allocation. Now, when you install a guest OS, you need to make sure you boot from that CD-ROM or an ISO first. It will if you don't do that, if you don't tell it to boot from the ISO, what it's going to do is going to try to boot from that empty virtual hard drive. That file, which has been formatted as though it were a partition of the appropriate kind, whether that's NTFS or HPFS or ext2 or 3 or 4 or whatnot. Anyway, it's an empty file system, and you're going to get a boot device not found error from the BIOS. You can use, as we said, an ISO image instead of a physical disk, and that's really a good way to do this. Those ISO images can be read at the speed of the hardware bus, not at the speed of the drive controller on your optical drive. You can use the file manager to change some global and local settings. Guest editions, like VMware tools in a VMware environment, allow you to do things like share folders, synchronize time, give you better video support, better mouse pointer integration. You can also, if you've got shared folders set up and you turned on drag and drop, you can also move files between the host and the virtual machine. The virtual machine will see that directory on the host machine as a new hard drive. Be aware that this is a security hole. You could exfiltrate or infiltrate data this way. Either infiltrate a password cracking tool or exfiltrate something like your shadow file and your password file or your SAM and use some external tools to crack those offline, where the hard drive, where the target OS can't notice the attack. You can create clones, you can link them or not link them. A linked clone will take a parent machine, and the child virtual machine state will depend in part on the state of the parent. A full clone, by contrast, is a complete separate copy. And what you do to the parent will not be reflected on the child and vice versa. So if you need a separate copy that you're going to do separate things with, a full clone is a better idea than a linked clone. If you want the linked clone to remain in relationship with the new drive, the new clone to have some ongoing relationship to the state of the parent, use a linked clone instead. Snapshots are an extremely good idea. You can save the state of a given virtual machine so you don't lose work. The downside is they proliferate. You're stacking up cruft on your hard drive. You don't need to keep every snapshot you've ever made, particularly after you take these snapshots before you make major changes to the system. After you've made major changes to the system, take another one. If that system persists in its new known good state, you can take the pre-upgrade snapshot and throw it away. You might want to keep the initial full configuration, and maybe every point at which you have just made a new change, a big change. Say you took your Windows 2016 member server and you made it an Active Directory domain controller. That's a huge change and something you would want a snapshot before and after, so that the next time you go through, you decide, you know what? It's got DNS. It's got DHCP. How about I add federated services or terminal services or whatnot? When you add those major services, major configurations like that, or even say you add a new zone to DNS, major new scopes to DHCP, that would be a good reason to take a new snapshot. But a week or two down the line, once that new normal has been tested out and established, toss some of the older snapshots. Now, there are some multiple hard disk drive modes: normal, write-through, shareable, immutable, and multi-attach. Make sure you understand these. And 7 different networking options: not attached at all, NAT, NAT network, bridged adapter, internal network, host-only, and generic driver. And to make it more complicated, because you can have 4 different virtual NICs in that VirtualBox VM, they don't all have to be in the same state. You can have one NIC in not attached, and another NIC in bridged mode, and another NIC in internal network, and another NIC in NAT mode. As long as you keep those, keep all the subnets differentiated. And now another fun thing you can do here that we talked about in a previous video. If you clone a VM, everything clones, the hard drive, the MAC address, all of it. If you want to keep those 2 VMs coexisting, one of the things you can do is open the new VM, go into that network adapter tab in settings, and there's a little blue circular arrow button over by your virtual MAC address. You click that button, it creates a new MAC address, and you're good to go again. Thank you for watching. This is the end of my video series on hands-on virtualization, virtual computing, Chapter 2. We will move on to Chapter 3 soon. If you feel free to rewatch any of these that you want, go back and watch something from Chapter 1 or a demo that I've made. If there's something you'd like me for class to make a demo about, let me know, and I will see what I can do. Thanks, and have a good evening.